Welcome to this lecture on analytic function. In this video, we are going to solve a problem on bilinear transformation. First, we see the concept. We call that bilinear transformation or Mobius transformation. So it will be in the form of W equal to AZ plus B by CZ plus D. Of course, there have a condition of AD minus BC not equal to 0. This we call it as Mobius transformation, and it maps extend the complex plane onto complex number union infinity onto itself, and it preserves the cross ratios and maps circles and lines to the circles and line determined uniquely by mapping a three distinct points to any other three distinct points. This is what main thing we are going to do in the problem. So simply they will give 3 points on Z and on the W. So we want to make a transformation W equal to f of Z with this cross ratio formula. W minus W1, W2 minus W3 as same, W minus W3, W2 minus W1 in the term of Z also the same. This can be used to find the explicit form of f of Z. F of Z means W. W represents the Mobius or bilinear transformation. We start with the problem. They have given a three values of Z, three values of W. Now they ask us to find the bilinear transformation. That means we want to find the f of t. F of t will be W. Okay. So I am taking this Z1 as -1, Z2 as 0, Z3 as 1 and W1 0, I, 3I. So now I am going to substitute in the cross ratio formula. So I will substitute the values of W1, W2, W3 and Z1, Z2, Z3. So on the next step, I want to simplify this term. So it will be of W into minus 2I, then W minus 3I into I will get cancelled. Then Z minus Z plus 1 into minus 1, then Z minus 1 into 1. So simply on the next step, it will be like this. I will get cancelled, and then again we want to find at last W. So we have to write the function at last in the form of W alone. So here I may multiply W inside, and here I will be get cancelled. So 2W, and here it is of minus, and here is a minus. So this minus will be get cancelled, and Z plus 1, Z minus 1. On the next step, this will be the last formation we did, and we multiplied, we do a cross multiplication, and then we will multiply all the terms with it. Okay, so then here it will be like this. Then finally on simplification, W 2Z minus Z, it will be Z, minus 2 minus 1, it will be minus 3, then minus 3I Z plus 1. So we need a W alone. So 3I Z plus 1 divided by, there should not be any other W terms. So this is what they are asking for our bilinear transformation. We call it as f of t. So finally, this will be a bilinear transformation. So we see one more problem with infinity. If they have given Z1 as infinity and here W3 will be infinity, that means we take of each of the value for 1, 2, 3 on Z as well as in the W, and we will write the cross ratio formula and we will substitute the values. Before substituting the values, you have to be very careful. So just see here, Z1 holds the infinity and W3 holds the infinity. So Z1, W3, here is our Z1, W3 is here. So before substituting, because any finite value minus infinity, it won't answer. We can't give any definite value. So before solving this, we may get one idea. We may take W3 from this term. So it may return as 1 divided by W3 into W minus W3 minus 1, then W2 minus W1. So W3 will get cancelled. Similarly, I may take Z1 from this term. So Z1 minus Z, W1, Z2 minus Z3, divided by z minus z3 and z1 into z2 by z1 minus 1. So z1 will get cancelled. Then if I substitute any values of w, so w2 by infinity, it becomes 0. And here also it becomes 0. Wherever I divide any definite value by infinity, it becomes 0. Here also it becomes 0. On the next step, simply for your identification, I have substituted the values of infinity. After that, if I am doing those things, I am taking out the w3 and w3 and then I am cancelling out. Then if I use to find the values on the remaining, it will be of w by I equal to I by w. So finally, w will be equal to I square by z. So I square will be minus 1. So w will be minus 1 by z.